Hello everyone, welcome to Decode Bytes YouTube channel, and in this tutorial we are going to cover everything you need to know about functional programming. This is a foundation tutorial. I am planning to have a series of tutorials related to functional programming. This should be a basic, a foundation tutorial for us to move forward to understand the rest of the topics related to functional programming. As you know, C# as a multi-paradigm programming language supports different paradigms, and one of them is functional programming. Starting from this series, as always, I will try to show you everything in practice. In our agenda, we have functional programming features in C#. We'll learn right now what we have in C# as a functional programming element. We'll talk about what is functional programming itself. We'll try to implement a functional approach in C#, and at the end, we'll talk why do you need a functional programming elements? Why do you need this approach in your programming? Let's first start from functional programming features in C#. I have a Visual Studio solution here. As you know, we have GitHub repository. I will add the repository link to the below of this video. And we have Decode Bytes solution in our repository. And we have tutorial functional programming in C# intro branch. And in this branch, we'll have all the required coding elements we need for this tutorial. In C#, we are having multiple paradigms element. We have object-oriented, aspect-oriented, functional, generic-based, etc. So we have functional programming elements that we are actively using daily basis in C#. Let's see what type of elements we are talking about. We have link queue, delegates, method extensions, tuples, local functions, immutability, mutable objects, and we have method chaining, for example, builder. These are going to be our functional programming elements in C#. Let's one by one dive into details. So this is our link queue example. So you see we have account information here, list of accounts, and I am applying group by and select link queue functionality. This link queue functionality is actually behind the scenes. It uses the idea of functional programming. Okay, so link queue is based on functional programming. This is really important to understand. We have delegates. If you want to learn more about delegates, we have two tutorials about C# delegates, one for covering the idea of delegates, the other one is advanced delegates like senior. So we are using delegates actively in our programming process. When you want to pass an expression, when you want to pass a code block to your method as an argument, you are using delegates. The idea of these delegates actually comes from functional programming. We have method extensions. If you want to learn more about method extensions, we have method extensions like a senior tutorial where I've covered everything related to method extensions. For example, I have list of accounts here, and I want to have additional functionality that is not going to be a built-in functionality, but from the project-based aspect, I have by city method. This is my method extension. As you know, we are building method extensions using static class and static method based implementation. This is our method extension that bases on functional programming idea. Next here we have tuples. Tuples also really important when it comes to build data, not heavily, but easily used data structures. So if you want to not to build a separate class, a separate data structure, but easily interact with your application, you are able to use tuples. So right now I have get user info method here. So you see this user info returns two information. In a classical way, we should build a special class here that consists from name and age property and return this information. But right now I don't need this type of data structure. I am building, let's say, in memory data structure, special data structure that helps me to avoid to create additional classes. That's how we are using tuples. Right now in my user info, let's see what we have. User info dot name, user info dot age. The next functional programming element in our C# is local functions. Local functions helps us to build function inside a method. If you are not going to use this method, this functionality outside of your method, then you are able to build your own local functions. These local functions will help you to separate your logic, and also from the complexity perspective, it helps a lot to write not complex but easily understandable code. The local functions also based on functional programming. So we have a lot of tons of elements from functional programming. So C# is not just object-oriented programming language. It is functional programming. It uses aspect-oriented programming, and etc. The next element here is immutability. We are actively using immutables when we build domain-driven design type of applications for domain models and etc. It doesn't matter if you are using domain-driven design approach or not. We are actively using immutable classes. It helps us to avoid a lot of issues. We'll have a separate tutorial related to immutability. For that reason, I'm just talking short about this one. So we have a point class here. So you see, for my point, I have only get properties. I don't have setrun based mechanism here. So if I want to have a separate method that will interact with my point, I am creating a new point. The purpose here is, if you have already created an instance, you shouldn't change it. If you want to manipulate it, you should have a new instance based on previous one. So I have 0.45, and with move x, I will get new point instead of modify this point. The next here is our method chaining. When you apply, for example, builder design pattern, you are using method chaining mechanism. For example, for link queue, you're actively using method chaining. You see, we have group by, then we have select. For example, here you can have, I don't know, where, etc. type of methods. So you have chaining. Okay, and in my case, I have computer builder special class here. Let's see what we have. First, we have just a computer that consists from CPU, RAM, GPU, okay? And I have a computer builder special type of builder interface. I want to build different type of computer here. So it provides me with CPU, with RAM, with GPU type of methods. And at the end, to build it, I should call build method. I have implementation computer builder here. It uses the same contract here to build special type of computer. Let's see. I want to build a basic computer here. So Intel i5, 8 GB build. This is my basic computer. And if I want to build a gaming computer, I will provide different arguments. So here, we are calling a chain of methods to build a complex object. That is also going to be a part of functional programming idea. Okay, so as you see, we have a lot of elements in C# that comes from functional programming. Okay, let's talk about what is functional programming. Functional programming is a programming paradigm that heavily relies on mathematical functions, okay? In short, it is a programming with mathematical functions. The class methods are not the same as functional programming functions. In most cases, you may think that, okay, I'm using C# object-oriented programming. I have a class with multiple methods. We use the method and function names interchangeably, but They are completely different, and I will show you how to write your proper functional programming functions. Okay? First, let's try to understand the mathematical function concept. The first concept here is same argument, same response. It means you have a function, you are providing some arguments to that function. If the arguments are same, the response should be same always. Okay? Let me show you one example. Here we have function programming in practice. The program says, let me just type a simple class here. Let's see, this is our account. I have public integer get calculated. Let's say it is get calculated data. Okay, calculated data. I am providing some value, data, and in my return, I am providing new random next to 4 multiplied by data. Great. Now let's go to the account. Let's create it. Instantiate account, calculated data. I'm providing 56. And for the second time, I am providing the same data as an argument. It means I should get the same response every time when I provide the same argument. But in my case, I have random functionality here, and I will get different data. So this is not a functional programming function, okay? This is a method, C# method, but this is not a function. If you want to have a function, your function should always return same data for same group of arguments or for same argument, okay? How to make it properly to be a functional programming function? There is no need to use this data here, and let's call it data2. In this case, data2, and we will always have the same response for the same arguments. That's how you should implement your functional programming functions. This is just one example. Let's switch to another. Okay, the second requirement here, all inputs and all outputs. If you want to specify a real mathematical function, a real functional programming function, your function should interact only with provided inputs. And your signature, method function signature, should define all the possible responses. Okay, let's go and create a separate example for it. Okay, let's say that we are not allowing negative numbers. Okay, in my case, I should check if data is less than 0 or data2 is less than 0, then I should throw exception, negative values are not allowed. But let's check our signature. In my signature, I'm actually interacting with data and data2. It is okay. We have partial requirements for functional programming, but in my method, I have integer as a response, and it means my signature indicates that I should always get integer value, always. But depending from my arguments, I may get exception here. So it means this is not honest signature. So when you apply same argument, same response, and all inputs with all outputs, you are applying method signature honesty rule. So in our case, your method signature, your function signature, your inputs, your outputs should be defined in your method. You should somehow specify that yes, I have exceptional case and my method will return some exception. In most cases, for example, in .NET source code, you will realize that there is comments, summary here, and in summary, they are specifying the exception. This is also one way of implementing, handling this issue, but this is not a functional way. Okay, if you want to handle it in a functional way, you should specify the exact response values in your signature. So it means I have integer and I may get argument exception, something like this will handle it. Okay, but this is a tuple based implementation. We are always using result pattern here, and we will have a separate tutorial related to result pattern, and I will explain everything there. For now, just understand that in this case we don't have a signature honest function. This is not a function. In this case, this is just a simple method. Okay, the next one here is method signature honesty. We already talked that the above two helps us to gain this method signature honesty. And the last one is referentially transparent. It means we shouldn't change or refer to the global state. Let me show you one example here also related to this one. Okay, let's say I have a special public integer. I have some, let's say, number here. Okay, let's make it get set, and we have get calculated data. When it calculates, it assigns. I'm just trying to provide a simple examples as much as possible, and we are just returning this number. The problem here is we are interacting with a global state here. So I don't know from this signature that I will interact with the internal data. This is our internal data, and my function writes some information to this number. And functional programming said that you shouldn't provide a function that interacts with your global state to refer or change it. Even if you have, let's say, 67 here and you are using it here, it is also not a proper functional programming function, because if you have two arguments in your method signature, you should only use these two arguments. It is not allowed to use additional argument or additional internal data. For example, internal data here, let's say 44. Even if you are not using this number but using the internal one, it is also not a proper functional programming function. So long story short, if you have two arguments, you should interact only with these two arguments. If your method returns integer, it means it shouldn't throw exception, it shouldn't return nullable information, etc. It should, for all possible cases, return only integer. This is called method signature honesty. Okay, now let's talk about why functional programming. Functional programming helps us to spend least time with documentation, because you have honest signature, you have all the things you need to understand what the function is doing, so you are spending least time with documentation. It is really easy to read and understand, because from the signature it is possible to understand what exactly function is doing. And also it is possible for us to build composable pipeline, because every function works as a separate element. They are referentially transparent. They are not modifying our global state. They are not referring to our global state. So they are independent components. You may think as like a ASP.NET Core application pipeline. So in ASP.NET, we have a pipeline middleware. So you may think the functional programming like a pipeline element. So you can build composable pipelines using functional programming. And also it helps us to deal with complexity. If you have a classical complicated method, you should first check your documentation. Then you should check if it throws exception or not. You should check if everything defined in signature is actually what it's supposed to do. So it is a bit complicated for the classical methods, but when it comes to functional programming, it is really easy for us to understand and deal with complexity. Well, that's pretty much all about our first tutorial related to functional programming. This tutorial purpose is to provide a strong foundation about functional programming that's going to help us in our rest of tutorials, rest of series related to functional programming. If you like my videos, please don't forget to subscribe, to hit like button, share, and see you in the next tutorials.